Okay, section 3. This is going to be split into two parts. Um, the first part is going to be um, identifying characteristics of polynomials and evaluating polynomial functions. The second part is going to be that second objective, basically, looking at end behavior of functions and trying to identify different characteristics based on a graph or based on the equation. Um, you will not be, at this point, having to graph polynomial functions. So, starting out, some of the different, I guess, ways that we classify polynomials and the ways that we classify their behaviors based on the degree. And in order to be able to find the degree, we need to have a polynomial in one variable. So this is literally exactly what it sounds like. It's a polynomial that only has one type of variable. This would be like, we'll just do an example of one of these. So I don't know, 2x to the fourth plus 3x squared minus x plus 1. Okay, that is a polynomial in one variable because we only have x's. So something that is not a polynomial in one variable would be if you had like 2x to the fourth plus 3xy. If we throw another variable in there, it's no longer a polynomial in one variable. In order to be a polynomial, also each of your terms have to be monomials. So we also want to uh, look at things that are not polynomials. If we have any of those things, it's going to make it not a polynomial in general. Therefore, it's not a polynomial in one variable. So these were things we made a list earlier. If we had like negative exponents, if you are dividing by a variable, okay, multiplying variables together, not okay, and square roots of variables. So if we have any of those things in a an expression, then it's not going to be a polynomial in general, therefore it's not a polynomial in one variable. Once we've classified or identified something as being a polynomial, then we want to be able to identify our leading coefficient and degree. So leading coefficient is one of our vocab terms. I think we already defined this at some point, so that's not what I wanted. I had changed this because I thought it was not on your sheet. If it's not on your sheet, I'm sorry. Just write it down anyway. But your leading coefficient is going to be the coefficient of the term of the highest degree. So we need to be able to identify the term with the highest degree. That's the degree of the entire polynomial. We have already defined degree before, but here, when we're looking at a polynomial in one variable, this is just going to be the power on the variable. Because we only have one variable in each term, we don't have to add powers, which is what we did previously. But this is slightly simplified because we're just looking at the exponents. Your degree is going to be the highest exponent in your polynomial. So for part of the assignment, I want to say it's a couple problems at least, 2, 4. It just says state the start over. State the degree and leading coefficient of each polynomial in one variable. if it is not a polynomial in one variable, explain why. So if we can identify that it's a polynomial in one variable, then we're going to state the degree and leading coefficient. If it's not, then we need to say, it's not because it's taking the square root of a variable, or there's two variables, something like that. So with these two examples, okay, the first one, 5x to the third minus 4x squared minus 8x plus 4 over x. Okay, so this one is not a polynomial in one variable because it's not a polynomial. That 4 over x is one of the things on the no list. So we would just say not a polynomial in one variable. Because of the 4 over x term. That's what's causing this to not be the polynomial in one variable. On the second one, each term appears to be following the rules of polynomialism. That sounds like colonialism. I don't know. I'm real tired by this point in the day, guys. So each individual term appears to be monomial. We have none of the things that would make it not. So then we look for the highest power. In this one, it would be this negative x to the sixth. So we can identify the degree as 6. And your leading coefficient would be the coefficient of the term that has a power of 6. This is a negative 1. If your polynomial is not written in the proper order, which would be the highest degree and then it decreases, then you're going to have to go looking for it. And then if it's just, if this was just a plus x to the sixth, always put that 1 in there to help you remember that that is a number that would be your coefficient. Polynomial functions, we're going to get into, like I said, looking at graphs, analyzing graphs. Eventually, you guys are going to be doing graphs, calculating values, filling out tables, all that fun stuff. First, though, we need to be able to evaluate polynomial functions. And our definition for this is that this is a continuous function, which just means that when you draw it, you can graph the whole thing without lifting your pencil. It's not like a bunch of dots or something. But this is a continuous function that can be described by a polynomial equation. And we are dealing with just polynomials in one variable. Okay, power function, we did yesterday. These are the parent functions of polynomial functions. These are the most basic of all of the polynomial functions. And you'll recall that these are going to be ones of the form like y equals a x to the n. So if you already have that written down on your vocab sheet, whatever we wrote yesterday is good enough. If you want to throw in there that this is the most basic, then yay, do that, I guess. So the next types of problems that you're going to be doing, and these are probably the most important, is being able to evaluate functions like this using function notation, and then also simplifying these without numbers if we throw in different variables or doing different operations on these functions. So part A on both of these is the like simpler version of this, where you have this function f of x equals x squared minus 2x minus 3, and we use function notation so that we can identify what function we're plugging these into. Okay, g of -1 means I'm going to plug it into the g of x function. F of 2 means I'm plugging it into the f function. And so f of 2, this is just telling me that we're going to replace any x's with 2. And then in this case we can evaluate this and simplify it to get a number for an answer. So here we're just plugging this 2 in for both instances of x. And then we evaluate it. So 2 squared is 4, minus 2 times 2, minus 3. 4 minus 4 minus 3 is 0. Okay, for B on this one, we got a lot going on here. We are going to do two separate substitutions here. And you can kind of treat this as like two separate problems. We need to figure out what this function would be, and we need to figure out what this one is, and then we're going to subtract them. In this first one, we are going to plug in 3c minus 4, and we're going to replace all of the x's with, that's not how you spell with 3c minus 4. So when I do that, I'm going to do 3c minus 4 squared minus 2 times 3c minus 4 minus 3. I didn't really give myself enough room here. Okay, I'm going to ignore that other part of it, the -5f of c, for the time being. We're going to just focus on this first part and simplify this. So simplifying this whole expression means, first of all, squaring this 3c minus 4. So that 3c minus 4 squared means I'm doing 3c minus 4 times 3c minus 4 minus 2 times, I'm just going to keep that the way it is for just a second. When we multiply this part, we are going to FOIL the 3c minus 4 times 3c minus 4. And when I do that, I'm going to get my first 3c times 3c is 9c squared. 3c times -4 is our outside, so that'd be -12c. Inside, another 12c, minus 12c. And then the last would be plus 16. In this second spot here, we are going to distribute a -2 through the parentheses. So we will have -6c, and then -2 times -4 would be plus 8 minus 3. Then, once we've gotten rid of all the parentheses, we can combine like terms. I'm going to start with my highest powered term, which is my 9c squared. There's no other c squareds, so we just have that. And then all of our c terms, we have a -12c, -12c, -6c. So -12 minus 12 minus 6 is a -30c. And then our constants, 16 plus 8 minus 3 would be 21. That's the wrong color, calm down. Plus 21. Okay, so we got the first part done. Second part is to plug in the c for x, so there's a little bit less to do here. But we're going to do, first we're going to replace x with c, and then you're going to multiply the entire thing by 5, by negative 5. Okay, so I'm going to take that negative 5, I'm going to put this outside of this parentheses. In my original function back here, I'm going to replace all of the x's with a c. So that one's fairly easy. Instead of x squared, it's just going to be c squared. And then minus 2c minus 3. And so all we have to do is distribute this negative 5 through the parentheses. I'm going to bring that down next to the green one. When we distribute, negative 5 times negative 2 would be positive 10c, and negative 5 times negative 3 is positive 15. Okay, now I can combine more like terms. Starting with our highest power, the c squared, so I have 9c squared and a negative 5c squared would be 4c squared. Negative 30c plus 10c would be negative 20c. And 21 plus 15 is 36. So this bad boy is our final answer to part B. Take a breath. I would say make a sandwich, but I'm assuming you don't have any sandwich making equipment with you. But dream of sandwiches and move on. Okay, on the second one, so this, we maybe should have done this one first. It's not as awful. When we plug in for A, we're doing g of negative 1, so that tells me I'm going to replace my x with negative 1. So in our function 2x cubed, we're going to do 2 times negative 1 cubed plus negative 1 minus 1. Okay, negative 1 cubed is negative 1 times 2 is negative 2. Minus 1 minus 1. Negative 2 minus 1 is negative 3. Minus 1 is negative 4. So when you're doing like f of a number or g of a number, you're going to get a number for an answer. If you have variables in there that you're plugging in, then you're going to get another expression for an answer. On B, we are going to replace x with y plus 1. So up here, instead of x cubed, we're going to have y plus 1 cubed. Make sure you're putting that in parentheses. Plus y plus 1 minus 1. In that one, the y plus 1 doesn't necessarily have to be in parentheses. I just think it helps identify, that you've plugged everything into the appropriate spots, and it keeps it in that same basic structure as the original function. So when we multiply this out, here we have to do this y plus 1 cubed first. So that means that I have y plus 1 times y plus 1 times y plus 1. In that second set of parentheses, they're actually unnecessary. I could just do the plus y plus 1 minus 1. And then we need to FOIL and then distribute some more. So we can only do this y plus 1 cubed 2 factors at a time. So I would start with 2 of them and FOIL that. And when we do that, we are going to get y squared plus 2y plus 1. And then multiply that by y plus 1. And over here on the tail end, we can cancel out those 1s and just throw that y on the end. With the now y squared plus 2y plus 1 times y plus 1, that I would say do with an expansion box. Do I have any room over here? Off to the side somewhere, I would have my y squared, 2y, 1, and my y plus 1. So multiplying that out, you get y cubed, 2y squared, and y squared, 2y, and 1. And your like terms, again, are going to be on that diagonal. So if we combine our like terms and simplify this, we're going to have y cubed plus 3y squared plus 3y plus 1, and then plus that y. We're so close. Next step would be to distribute that 2 that's on the left. So I'd have 2y cubed plus 6y squared plus 6y plus 2, and then plus y. One last step, we can combine the 6y and the y. So our final answer would be 2y cubed plus 6y squared plus 7y plus 2. I'm going to highlight that so it stands out. So that's our final answer there. When you are doing these on the homework, some of them are more awful than others. But if you just take it piece by piece, it's not the worst thing in the world. I will say that on numbers 9 and 10, okay, 9, for instance, that's still the highlighter. Okay, for number 9, it asks you to do 6c of 4a plus 2d of 3a minus 5. Okay, do not confuse this with multiplication here. This is not like 6c times 4a. Okay, this is doing c of 4a and then times 6. And this is doing d of 3a minus 5 and then times 2. So your steps here on this first one, in c of x, you're going to replace x with 4a. Then you're going to multiply by 6. Okay, on this portion of it, you're going to, in d of x, you're going to replace x with 3a minus 5. Then, once you've simplified that, you're going to multiply it by 2. Okay, the notation there can get tricky and it can get confusing, but the fact that we are dealing with functions means that you're looking at this and reading it as like c of 4a and d of 3a minus 5, not multiplication. Hopefully that makes some semblance of sense. We will finish this section on Monday, and if you have further questions, we can clarify those. We'll take maybe 10-15 minutes to go over any questions you have from this week that I have not answered yet. Good luck and have a good weekend.